Okay, for this example, we're going to identify and sketch the surface and space of the equation z equals x squared plus 4y squared. This follows the same pattern as the elliptic paraboloid, so we're going to do the traces, the xy, the xz, and the yz traces. Starting with the xy trace. For the xy trace, you let z equal 0. Our equation becomes 0 equals x squared plus 4y squared. Or you can try to solve this for x or for y and realize that the only value for x and y, where if you were to add up those values, x squared plus 4y squared equals 0, the only values for x and y that make that equation true would be a single point, that is the point 0, 0. Okay, x squared plus 4y squared equals 0 only when x and y are both 0. So you get that single point. Let's do the xz trace. For the xz trace, you let y equal 0, and your equation becomes z equals x squared. We're going to sketch this using an x-axis and a z-axis in 2 dimensions. If z is equal to x squared, when x is 0, y is 0, this is a parabola. It does open up. When x is equal to 1, z is equal to 1. When x is equal to negative 1, z is equal to positive 1. And you get this parabola that opens up in the xz plane. And the last trace would be our yz trace. Let's do that over here. The yz trace, when x is equal to 0, you get the equation z equals 4y squared. So we'll draw that one using 2-dimensional graph. We have our y-axis and our z-axis. Now this is a parabola that opens up, but that 4 in front makes it a very narrow parabola. In fact, when y is equal to 1, z is equal to 4. So it's going to be very narrow parabola that opens up. We're going to combine these 3 sketches on a single graph in space. Okay, we have x-axis, y-axis, and z-axis. Point 0, 0 is our first trace. The parabola that opens up around the z-axis in the xz plane is a parabola that opens up. You can think of this point here at 1, 1 and at negative 1, 1. And then finally the yz trace. When y is equal to 1, the z is equal to 4. So it's a very narrow parabola that opens up. So all of those combine together to give you this elliptic paraboloid. Kind of like a bowl that's been squished together, so it has a wider and more narrow components of the board.